Hello friends, this is our third lecture of our second chapter, alkyl halide and aryl halide. Now, in last two lectures, we have studied what is meant by alkyl halide, halogen derivatives of alkanes, its types, what is meant by alkyl halide. It's also further we studied the types of alkyl halides. Along with that, in last lecture, we have studied preparations of alkyl halide. Now, in this lecture, we have to move towards a new topic, chemical reactions of alkyl halides. Alkyl halide is the main functional group which has wide varieties of chemical reaction. From alkyl halide, we may prepare alcohols, we may prepare alkene, we may prepare many compounds. Okay, that's why we have to move towards our chemical reactions of alkyl halide. The first reaction which we have to study is nothing but hydrolysis. This hydrolysis, we may say that alcohol formation. In case of this reaction, we have to reflux alkyl halide with aqueous solution of alkali. That is, we have to use aqueous KOH or aqueous NaOH. We have to reflux In this case, we have to reflux alkyl halide with aqueous alkali solution. For example, for that purpose, we use aqueous KOH and aqueous NaOH. Or sometimes, if we heating or on heating with moist silver oxide, we also prepare alcohol as a product. Or on heating this alkyl halide with silver oxide, we obtain alcohol as a product. The first reaction of this chapter is nothing but hydrolysis. Now, this hydrolysis is further called as alcohol formation. In this case, we have to prepare alcohol. Now, we know that when alkyl halide is refluxed with what? Is refluxed with alkali solution. And that alkali solution is nothing but we may use aqueous KOH or aqueous NaOH. Or if instead of this alkali solutions, if we use silver oxide, that is moist silver oxide, it means we have to use Ag2O in presence of water, which liberates AgOH, and this AgOH is used as a nucleophile in this hydrolysis reaction. Now we have to see what happened in the reaction. We know that in this case, when alkyl halide, that is RCH2X, is treated with aqueous KOH, or instead of this we may use aqueous NaOH. This halogen atom in this case or this halogen atom of this alkyl halide is replaced by OH, and if we use KOH we will obtain KBr along with this, or if we use NaOH as an alkali solution then we obtain NaX as a further product. Okay, if we use NaOH then we obtain NaX as a product. Instead of NaOH, if we use KOH then we obtain Kx as a product. Now for example, when I treat this ethyl bromide with this silver oxide, that silver oxide may be treated as moist silver oxide. It means if we use this silver oxide in presence of what? In presence of water, this mixture gives the formation of AgOH, This AgOH is nothing but a base or nucleophile which replaces this bromine atom from this alkyl halide by its OH negative. Now we will obtain this ethyl alcohol as a product with the formation of what? AgBr, with the precipitation of what? This AgBr. This is the first hydrolysis reaction when any alkyl halide is treated with KOH, NaOH or moist silver oxide. We will what? We will obtain on hydrolysis alcohol as a product. This is the first reaction. Now second reaction of this chapter, formation of alkyl nitride and nitroalkanes. We know that nitro group is nothing but this is the nitro group. If we use this nitro group with Ag, sometimes we may use this group. Now in this case, that is in case of this NO2 group, we know that this nitrogen atom also has a lone pair. It means I have to say you that this NO2 group behaves as a bidentate nucleophile. In case of what? In case of formation of alkyl nitride and nitroalkanes, we use what? NO2. That NO2 behaves as a what? Bidentate nucleophile. It means this oxygen atom and this nitrogen atom behaves as a nucleophile. If this oxygen atom behaves, or this side behaves as a nucleophile in this reaction, then we obtain alkyl nitride as a product instead of this oxygen atom. If nitrogen atom attacks the alkyl halide, then we obtain what? Nitroalkane as a product, which we have to see one by one. If a alkyl halide, if I treat this ethyl chloride with this nitroalkane and on this alkyl halide, if this oxygen, here in this case, if oxygen atom acts as a nucleophile and it prefers to attack on the electrophilic carbon atom to which halogen atom is directly attached, then as soon as it will attack on this electrophilic carbon atom, the Cl atom will be removed and we obtain this alkyl nitrile, that is alkyl nitride, that is ethyl nitride as a product. Ethyl nitride as a product. We know that here upcoming nucleophile oxygen atom is treated as the nucleophile, whereas same ethyl chloride when treated with this silver nitride, when this ethyl chloride is treated with silver nitride and the nitrogen atom present in this AgNO2 group will act as a nucleophile. Here in this case, if this nitrogen atom acts as a nucleophile which attacks on this electrophilic carbon atom. Now this electrophilic carbon atom, as soon as this nitrogen atom attacks on this electrophilic carbon atom, this chlorine itself removed to form this nitroalkane as a product. In formation of alkyl nitride and nitroalkanes, if oxygen atom acts as a nucleophile, we will obtain what? Ethyl nitride as a product. Instead of this oxygen atom, if this nitrogen atom acts as a nucleophile, then we obtain nitroalkane as a product. Here in this reaction we obtain nitroethane. We obtain nitroethane as a product. This is the second reaction of this chapter. Like this reaction, another reaction is also there, which is nothing but the synthesis of alkyl nitrile and isonitrile. Like this, there is another reaction. Okay, this is nothing but formation of alkyl nitrile and isonitrile. Now we have already seen a reaction in which bidentate nucleophile will be used. Now in this reaction we have also another bidentate nucleophile, that is cyanide. We know that the carbon atom of cyanide carries negative charge, and the nitrogen atom present in cyan also has a lone pair. That lone pair means a pair of electron which will be used for a donation. That's why this cyan is also a bidentate nucleophile. Now, when this bidentate nucleophile is treated with alkyl halide, which we have seen in our previous reaction. Now, when alkyl halide is treated with a bidentate ligand, a bidentate nucleophile, like cyan, that is AgCN, KCN, or instead of these we may use NaCN. Out of these three, which one will be used as a bidentate nucleophile? When this bidentate nucleophile is treated with what? Is treated with alkyl halide, we will obtain alkyl nitrile or alkyl isonitrile as a product. We will obtain what? Alkyl nitrile or isonitrile as a product. This will be the statement of this reaction. Now we have to see actual course of reaction. Now we know that when any alkyl halide, if I use this methyl bromide and this methyl bromide, if I treat with this AgCN, silver nitride, now we know that the carbon atom of this molecule has a negative charge. It is a metal which is positively charged. It will neutralize this molecule. We know that this negatively charged carbon atom in this case will try to attack on this electrophilic carbon atom, because this bromine atom, which is higher in electronegative, directly attached to this carbon atom, it becomes electrophilic. Now obviously this carbon atom, which is nucleophilic in nature, try to attack on the carbon atom, and this Br atom will be eliminated to form alkyl nitrile, as a product. Here in this case we form CH3CN, that is methyl nitrile or acetyl nitrile as a product. We obtain acetyl nitrile as a product. Now instead of this carbon atom, this nucleophilic carbon atom present in this AgCN, if the nitrogen atom acts as a nucleophile, if in case of this reaction, instead of this carbon atom, nitrogen atom acts as a nucleophile, then what will be the case? Now if I treat this ethyl chloride, you may use any alkyl halide. Now if I treat this ethyl chloride, we know that due to higher electronegativity, chlorine atom in this case try to attract an electron towards itself. As it attracts electron from this carbon atom becomes partial positive, means it becomes electrophilic in nature. Now if I treat this ethyl chloride with what? With CN or AgCl, and the nitrogen atom which has a lone pair acts as a nucleophile here. Now this nucleophilic nitrogen atom try to attack on this electrophilic carbon atom, and this chlorine atom will be eliminated. This chlorine atom will be eliminated when this nitrogen atom try to attack on this carbon atom. When this nitrogen attaches to this carbon atom, this chlorine will be eliminated, and we obtain this, that is ethyl isonitrile as a product. This is all about the formation of alkyl nitrile and isonitrile. Thank you.